become a residential journeyman electrician, firstly, contact the local electrical union. Joining a recognized electrical union, such as the International Brotherhood of Electrical Workers, often abbreviated as IBU, can provide access to apprenticeship programs and valuable industry resources. Secondly, pursue an apprenticeship program. Enroll in a formal apprenticeship program. These programs typically last 4 to 5 years and combine classroom instruction with practical on-the-job training. Thirdly, focus on classroom instruction. During your apprenticeship, you'll take courses covering essential topics such as electrical theory, code interpretation, safety procedures, and practical wiring techniques. Fourthly, gain on-the-job training. Apprenticeships involve working under the direct supervision of a licensed electrician. This hands-on experience allows you to complete various projects and develop your skills in the field. Fifthly, prepare for exams and licensing. Upon completing your apprenticeship, you'll need to pass written exams administered by your state's regulatory agency to obtain your journeyman electrician license. It's important to emphasize your existing experience. Highlight your extensive volunteer hours and proven wiring skills to showcase your aptitude in the electrical field. Consider enrolling in a pre-apprenticeship program. Certain programs offer specialized training and support to help individuals prepare for and succeed in apprenticeship programs. Networking with electricians is very important. Attend industry events, connect with electrical professionals, and build relationships. This can provide valuable insights and potential opportunities. Continue your education. Stay up to date on the latest code changes and industry trends by participating in workshops, seminars, and online courses. Becoming a residential journeyman electrician offers several advantages. Firstly, it's a stable and in-demand career. Secondly, there is high earning potential. Thirdly, there is job satisfaction from providing essential services. And fourthly, there are opportunities for personal and professional growth. As you transition into the electrical field, your prior experience and skills will be invaluable. Emphasize your proficiency in wiring techniques, code compliance, and problem solving. Remember that continuous learning and professional development are essential for long-term success as a journeyman electrician. The electrical code is a comprehensive set of standards designed to ensure the safe installation and maintenance of electrical systems. Understanding and adhering to the code is crucial for every electrician. The National Electrical Code, often abbreviated as NEC, is updated every 3 years, so staying current with the latest edition is very important. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for different types of electrical systems and equipment. Familiarizing yourself with the code will not only ensure safety but also improve your efficiency and effectiveness as an electrician. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. Chapter 1 covers general requirements, including definitions, wiring methods, and calculations. Chapters 2 through 4 address specific wiring systems and equipment, such as branch circuits, feeders, and services. Chapters 5 through 7 cover special occupancies and equipment, such as hazardous locations, healthcare facilities, and swimming pools. Chapter 8 addresses communication systems, such as telephone, data, and cable television. Chapter 9 provides tables and examples for calculating conductor sizes, conduit fill, and other electrical parameters. Overcurrent protection is a critical aspect of electrical safety. Overcurrent devices, such as circuit breakers and fuses, are designed to protect electrical circuits and equipment from excessive current flow, which can cause overheating, fires, and other hazards. The NEC specifies the types and sizes of overcurrent devices required for different circuits and equipment. Circuit breakers are automatic switches that interrupt the flow of current when an overload or short circuit occurs. They can be reset manually, allowing the circuit to be restored after the fault is cleared. Fuses are one-time devices that melt and break the circuit when an overcurrent occurs. They must be replaced after they have blown. Grounding is another essential safety measure in electrical systems. Grounding provides a low impedance path for fault current to flow back to the source, allowing overcurrent devices to quickly trip and de-energize the circuit. The NEC requires grounding of electrical equipment and systems to protect against electric shock hazards. Grounding electrodes, such as ground rods and water pipes, are used to connect the electrical system to the earth. Bonding is the process of connecting non-current carrying metal parts of electrical equipment together to create a continuous electrical path. Bonding helps to minimize the risk of electric shock by ensuring that all metal parts are at the same potential. Wiring methods are the techniques and materials used to install electrical conductors. The NEC specifies various wiring methods, including conduit, cable, and open wiring. Conduit is a rigid or flexible metal or plastic tubing used to protect electrical conductors. Cable is an assembly of two or more conductors enclosed in a protective jacket. Open wiring is a method of installing conductors without any enclosure. Electrical calculations are essential for determining the correct size of conductors, overcurrent devices, and other electrical components. The NEC provides tables and formulas for performing these calculations. Conductor sizing is based on the ampacity of the conductor, which is the maximum current it can carry without overheating. Overcurrent device sizing is based on the ampacity of the conductor and the type of load it serves. Voltage drop is the decrease in voltage along a conductor due to its resistance. The NEC recommends limiting voltage drop to ensure that equipment operates properly. Short circuit current calculations are performed to determine the maximum current that can flow in a circuit during a short circuit. This information is used to select overcurrent devices with adequate interrupting ratings. Electrical safety is paramount when working with electrical systems. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow lockout-tagout procedures to prevent accidental re-energization of circuits. Be aware of potential hazards, such as exposed wires, wet locations, and overhead power lines. Never work on electrical equipment when you are tired or distracted. Seek assistance from a qualified electrician if you are unsure about any aspect of the job. Electrical theory is the foundation of understanding how electrical circuits work. It covers topics such as voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. Power is the rate at which electrical energy is used or generated. It is measured in watts. Ohm's law is a fundamental law of electrical theory that relates voltage, current, and resistance. It states that voltage equals current times resistance, expressed as volts equals amps times ohms. Series circuits are circuits in which the components are connected end to end, so that the same current flows through each component. The total resistance of a series circuit is the sum of the individual resistances. The voltage drop across each component in a series circuit is proportional to its resistance. Parallel circuits are circuits in which the components are connected side by side, so that the voltage across each component is the same. The total current in a parallel circuit is the sum of the individual currents. The reciprocal of the total resistance of a parallel circuit is equal to the sum of the reciprocals of the individual resistances. Combination circuits are circuits that contain both series and parallel components. To analyze a combination circuit, you must first simplify it by combining the series and parallel components. Residential wiring involves the installation of electrical systems in homes and apartments. It includes branch circuits, lighting, receptacles, and appliances. Branch circuits are the circuits that supply power to individual outlets and lighting fixtures. Lighting circuits typically use 15 amp or 20 amp circuit breakers. Receptacle circuits typically use 20 amp circuit breakers. Appliance circuits may use 30 amp, 40 amp, or 50 amp circuit breakers, depending on the size of the appliance. Receptacles are electrical outlets that provide a convenient way to plug in appliances and other electrical devices. Standard receptacles are rated for 15 amps or 20 amps at 125 volts. Ground fault circuit interrupters, often abbreviated as GFCIs, are special types of receptacles that are designed to protect against electric shock. They are required in wet locations such as bathrooms, kitchens, and outdoor areas. Lighting fixtures are devices that provide illumination. They come in a variety of styles and sizes. Incandescent lamps are traditional lighting fixtures that use a filament to produce light. Fluorescent lamps are more energy efficient than incandescent lamps. Light-emitting diodes, often abbreviated as LED, are the most energy-efficient type of lighting fixture. Appliances are electrical devices that perform specific tasks such as cooking, washing, and heating. Major appliances, such as refrigerators, ovens, and washing machines, typically require dedicated circuits. Small appliances, such as toasters, blenders, and coffee makers, can be plugged into standard receptacles. When working with electrical systems, it's important to follow all safety precautions and guidelines. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow lockout-tagout procedures to prevent accidental re-energization of circuits. Be aware of potential hazards, such as exposed wires, wet locations, and overhead power lines. Seek assistance from a qualified electrician if you are unsure about any aspect of the job. Additionally, understanding the specific requirements for residential electrical installations is essential. This includes knowing the proper wiring methods, grounding techniques, and overcurrent protection measures. Always refer to the latest edition of the NEC for the most up-to-date information and guidelines. Remember that continuous learning and professional development are key to a successful career as a residential journeyman electrician. Keep your skills sharp by staying informed about industry trends, code changes, and new technologies. By investing in your education and training, you can ensure that you're always at the top of your game and providing safe, reliable electrical services to your clients.